So hello all, and also a very warm welcome from my side. I'm very glad to give you a very short overview of the commercial vehicle industry's journey towards autonomous driving. And also we will have a short look on the main drivers and hurdles. Some of them you already heard from Sunny, because she also focused on them as well. And we see also the differences between the pass car and the truck industry. But before we deep dive into that topic, I believe by walking over the fair, all of you have witnessed the latest updates in e-mobility, for sure. It's all about here e-mobility, but also in the autonomous driving sector, we have done very significant progress in the pass car. Highway pilot is in series, available in the modern pass cars. We have robotaxis and people mover short to come. And also the commercial industry, truck industry, has done updates and showcased in the latest focus of the new use cases like hub-to-hub, very good progress. When we are looking on the main drivers and hurdles which we face, so let's first look on the drivers. As stated before, we see also the driver shortage gap as the main driver of our industry. So, Sunny mentioned it before, we have around about 80,000 people gap in the US, same in Germany, 80,000 people, Europe overall, 400,000 people, and it's getting even severe. It's a threat. Is the reason why the market is so interested in different solutions. A second driver is still the promise of the virtual driver to save accidents, to reduce the number of accidents, as still 93% of all accidents are still done by human drivers. So here, of course, this is one major driver. The third point would be the total cost of ownership. So in comparison to pass car, in commercial vehicle, all focuses on cost. And here I have a dedicated slide which shows you the main cost drivers and how we can save here some money. Another driver is that the current technology, especially when it comes to less complex use cases, we already have the technology which is ready to scope here with the challenges, so we don't need additional infrastructure which avoids here efforts and costs. And also, globally spoken, all legislators are shaping the legal frameworks and enable us to go for autonomous driving. On the hurdle side, we have, of course, also still not really defined all liabilities. So here I have also a slide for more information. We have the social acceptance as a hurdle, means we as humans, we need to accept that a virtual driver is in front of us, how a virtual driver reacts in the traffic, and of course, finally, we need to accept that the virtual driver and the system does failures, even will make accidents. And this we need to accept to a certain extent. Maybe the biggest hurdle we see is the technical one still, and the volume we currently have. Technical, in comparison to pass car, in the truck industry, we have a huge variety. So we have rigid trucks, we have tractors and trailers, we have special applications on the trailers, we have dangerous goods with liquids, and all of this makes it extremely hard to find spaces for sensors, and also we need a special focus on the vehicle dynamics. It's much different to a pass car. So this is a big challenge for our industry. When we focus, or when an overview on the regions, they are very different. So it's not everywhere the same drivers behind. In North America, we have big fleets which are pushing the market. They are demanding, and they have the size to convince the OEs to bring certain technologies. Meanwhile, in EU, of course, we have a strong OE-driven market. Here, the OEs have their dedicated platforms, and the market is taking what they are delivering. And while in China, super governmental driven, here we have dedicated projects which are funded. Government is taking care that, if necessary, infrastructures are available to then do the demos for their local players. So all in all, still, even if maybe e-mobility has the highest priority, we see that autonomous driving is the industry trend still, beside e-mobility, which our market is very interested in. So why do we think now that within the commercial industry we see bigger benefits and a faster movement than in the past car? Because the preconditions are much more compelling than in the past car sector. Means we have a business case, so we can save cost. I will show you in a minute. Then technology is ready for the new focused hub-to-hub, very simplified use case, so it's even less complex than a robotaxi. Then we have the necessary legislation already in place, and maybe one big change which was very done recently is the transformation of the classic development from only OE-driven to a strong cooperation and collaboration of OE, Tier 1s and AI to cope with the complexity and also with the needed resources. Before I go into the more detailed description of the business case and the hub-to-hub use case in particularly, I wanted to show you also the overview of the automation levels. I think this is not something new. Yeah? Already JJ before from Mobileye has told this. Also Sunny made a good overview on this. But still, let's focus on what benefit come along with which level of automation. So here we see from the level 1 and 2, mainly focusing on safety and comfort. All of those functions you experience definitely by yourself, I think, in a modern pass car. So like they are already mandatory partially. Only when we enter the level 3, level 4, level 5, so meaning in the same wording like JJ, eyes off, hands off, eyes off, and full automation, we can lever the economical benefits. So a detailed look now to the total cost we see by operating a truck. So here you see the chart, and first of all, you see it shows the cost per driven kilometer. We put all of the cost in 4 groups. So we have the cost for acquiring, we have the cost for the driver, for energy, and for the operation. And obviously, it's clear when you change to a full autonomous truck, you need to increase. The costs are increased because of the necessary sensors, and also of all of the redundancy you need for the safety critical systems. But maybe first of all, the bars, they show from the left to the right a standard vehicle, lower level 4. Then the second bar shows this, particularly the hub-to-hub use case, which is the most interesting in the short term. And then the 3 remaining bars compare also the full automation with combustion engine, fuel cell vehicles, and battery electric vehicles. So the additional costs for acquiring an autonomous vehicle are more than overcompensated by the reduction of the truck driver costs. So there will, of course, be a remaining portion, especially in the hub-to-hub use case, because only partially the driver is taking out. And also we assume that there will be a remaining license for the virtual driver remaining, which you can see then in the full automation. When we're looking on the energy costs, the big saving is coming, of course, with the new technology, with the fuel cells and battery electric vehicle. But also experts assume that by introducing a virtual driver, the driving behavior of the virtual driver is much more efficient, much smoother than the human drivers are. So they are assuming even that you can save energy and also wear up to 2.5% in a hub-to-hub use case, or even then with the full automated driving. When we are talking about operation costs, there is not a big change. Yeah? It's all the same. It's maybe a little more, less administrational cost, as you don't need to deal with such a lot of people inside your fleet. Now, let's look in the detail of the idea of a hub-to-hub use case. It's very simple, so it's all about reducing complexity. So we want to avoid urban regions, environments, because they have the highest complexity. So we have a distribution center. In between, we have then a very well-defined and trained road. and then we are entering again a distribution area again. So inside this confined area, the distribution center, of course you can also do automatization. Here still the economical benefit is not so high. It's a niche application, there's no volume scaling effect, but you can do remote control. There will be done the departure checks. Then the virtual driver can take over for that predefined road and will then hand over back in the final location. Now we have discussed the main drivers. We see now we have the hurdles. And this is more or less very similar slide to Sunny's, leaving out the level 2++. So this is just our predicted global adoption rate, and it's matching pretty well to each other. So you can see that we assume a low scenario and a high scenario. The low scenario when everything stays caution, yeah, we only do the minimum, we replace the driver gap, while the upper scenario where the vehicle availability is the limiting factor. If we would have looked 2 years back on the same slide, then you would have seen that the figures for 2040 have been expected in 2030. So there was a huge shift in the industry, not because of the missing need, but because of the focus on e-mobility globally, and secondly, also because of the technical challenges we face still. So next to that hurdle, we have also the open liability I said before. So still, it's not finally clear. Nobody has released a HUD system fully. So there are no standards, no guidance given currently. So this needs to be done to prove the test coverage. We have still liability shares we need to discuss between OEs, AD providers and operators. Today it's super clear. The insurance is at the vehicle owner, but how is it with new business models, if we have transport as a service? The product liability is currently at the OE. How shall that be in the future if the OE is just providing a chassis, a rolling chassis? AI company is putting the driver on top. So this needs to be solved in the future. Also, the current driver responsibility. So he needs to make the departure checks. He needs to prepare the vehicle, freight fixation, lights check. So when he's then handing over to the virtual driver, everything is fine, but you can imagine that on the road something could happen. The freight gets loose, or the fixation is breaking, something is going outside of the truck or of the trailer. The driver, the virtual driver, will never ever recognize what happens then if there is an accident. So all of these things, we need to find solutions to ensure a good way forward. Finally, on my last slide, I want to show you a bit what Knorr-Bremse stands for. We are a safety system supplier. We are providing solutions from the level 1 to the level 5. So we are offering our ADAS system with all necessary mandated and extended safety functions, also comfort functions, which all of you are aware. And if we enter the autonomous arena, next to the base systems, brake, steering, we offer then for fail operational paths, very smart concepts for confined areas up to public roads. So, thanks for your attention. I hope my presentation gave you a good insight into the commercial industry sector. I hope if you have a good stay, remaining stay on the trade fair, and thanks a lot for your attention.